Now this is mechanical engineering, force analysis in dynamics of machines. What is inertia force? Inertia force is an imaginary force. It is an imaginary force acting on a body. When it acts upon a body, it brings the body to an equilibrium position. So the inertia force, when it acts on a body, brings the body to the equilibrium position. It is numerically equal to the accelerating force in magnitude but opposite in direction. The inertia force is equal to the accelerating force in magnitude, but the inertia force is exactly opposite in direction, that is at 180 degrees to the accelerating force. So here inertia force is minus accelerating force. Right. Now here you see, this is the body. Consider a body of mass m. Right? It is moving in this direction. A is the acceleration of the body. Therefore, accelerating force is ma. Accelerating force is mass of the body multiplied by the acceleration. It is, the body is subject to, let us assume that the body is subjected to acceleration. Accelerating force on the body is ma. There is another force called inertia force. So this is an imaginary force. The inertia force acts on the body in the opposite direction to the accelerating force. When the body is moving towards right, the inertia force acts towards left. The magnitude of the inertia force is equal to the accelerating force but opposite in direction. Therefore, inertia force is equal to minus accelerating force. Therefore, inertia force is equal to minus ma, where m is the mass of the moving body, a is the linear acceleration of the center of gravity of the body. This is linear acceleration of the center of gravity, center of mass of the body. So this is the equation for inertia force. Now inertia torque. What is inertia torque? Inertia torque is an imaginary torque. It is an imaginary torque which when applied on the rigid body brings the body to an equilibrium position. It is equal to the accelerating torque in magnitude but opposite in direction. Now let us see. This is a body. Let us consider this is a body. This is subjected to a resultant force like this. It is subjected to a torque in this direction, right? T, right? The torque because of the force here. This is the distance from the center of mass. This is center of mass, center of gravity, or center of gravity, right? So a force is acting and it tries to rotate the body in this direction. Therefore, it's a torque, right? So the accelerating torque is equal to F into, this is R. So accelerating torque is equal to, I can take F into R. F into R is the accelerating torque, right? So inertia torque Ti is equal to minus T. Inertia torque is equal to minus T. That is, there is here that the accelerating torque T is equal to F into R. This tries to rotate the body about the center of gravity in the anti-clockwise direction. There is another torque called inertia torque which will try to rotate the body in the opposite direction, that is in the clockwise direction. This torque is called inertia torque. Therefore, inertia torque is equal to the accelerating torque in magnitude but opposite in direction. T is equal to accelerating torque. Ti is the inertia torque. T is equal to F into R, equal to accelerating torque, and Ti equal to inertia torque. Therefore, inertia torque is equal to the accelerating torque in magnitude but opposite in direction. This is what about the inertia torque.